In today's lesson, we'll be learning about the properties of quadratic relations. When you graph a quadratic relation, it resembles a curved line. We call this a parabola. Let's reflect on what we learned about linear relations. A linear relation, when graphed, resembles a straight line. Meanwhile, the general equation of a line in slope-intercept form is y equals mx plus b. If you recall, m represents the slope and b represents the y-intercept. We're going to be seeing y-intercepts once again, but we are not going to talk about slopes during this topic. In our first example, we're going to take a look at a quadratic relation. Let's take a look at the very first property right over here. That is called a vertex. The coordinates of this vertex are 4 and -3. The y-intercept is a point at which the quadratic relation crosses the y-axis, and that point is right over there, which makes the y-intercept 13. The x-intercept is the point at which the quadratic relation crosses the x-axis. There could be one x-intercept, there could be two x-intercepts, or there could be no x-intercepts. In this situation, we have two x-intercepts. Let me label that right over here. And I forgot to label the y-intercept, and I'm just going to do that right now. Therefore, the x-intercepts are what looks to be about 2.2 and what looks to be about 5.8. These are approximate. As you might have noticed, a quadratic relation is symmetrical. The axis of symmetry divides the quadratic relation into two equal parts. It also crosses through the vertex. I'm going to draw that. I'm going to label this axis of symmetry, but instead of writing the entire word, I'm just going to write AOS. Now, the equation for the axis of symmetry is a little bit tricky. If you recall, this is a vertical line, and the equation for a vertical line is x equals, you need to take a look at what number it passes through in the x-axis, and that is 4. Therefore, the equation is x equals 4. Next, let's take a look at the direction of opening. A parabola can either open upwards, a smile, or it can open downwards, which would be a frown. In this case, it is smiling, so it is opening upwards. And last but not least, we have to determine if there is a minimum or maximum. I want you to take a look at the vertex. The vertex is at the lowest point of the parabola. Therefore, it is considered a minimum. Now, depending on what resource you use, you can write the minimum as a coordinate, or you can write it as a single value, the y value. I'm going to write it as a single y value. So let's just take a quick look at where that y value is, and that y value is -3. We're going to be using the exact same steps to describe the properties of this new quadratic relation. Let's begin by labeling our vertex, which is right over here. The vertex coordinates are 4 and 10. Remember, the y-intercept is a point at which the quadratic relation crosses the y-axis. That occurs somewhere over here. And let's label this the y-intercept. That appears to be -6. Now let's look for the x-intercepts. Remember, the x-intercept is a point at which the quadratic relation crosses the x-axis. In this situation, it looks like we have two x-intercepts. I'm just going to label that x-intercept, and I'm going to label that over here. The first x-intercept appears to be possibly 0.8, and the second x-intercept appears to be possibly 7.2. Next, let's label our axis of symmetry. Remember, the axis of symmetry crosses through the vertex. So let's do that. Instead of labeling it axis of symmetry, let's just label it AOS. And if you recall, this is a vertical line, and the equation for a vertical line is x equals. We need to take a look at where that axis of symmetry crosses the x-axis. It crosses it at 4. Therefore, the equation of this vertical line is x equals 4. In terms of the direction of opening, if you remember, it can either open upwards or downwards. Upwards would be a smile, downwards would be a frown. Since we have a frown, the direction of opening is downwards. And last but not least, we want to determine if there's a minimum or maximum. You want to take a look at the vertex. In this situation, the vertex is at the highest point of the parabola, which makes it a maximum. And I'm just going to make a little note for myself over here to see what the maximum value is, and the maximum value happens to be 10. And those are the steps you need to take in order to describe a parabola.